Hello, my name is Montgomery, and today I'm going to be talking about the DHCP protocol, what it is, what it does, how to configure it, and why it is relevant today. What is DHCP? DHCP stands for Dynamic Host Configuration Protocol, and as you can probably guess, it dynamically configures hosts. In English, this means it makes the network a lot easier than it needs to be, as long as you know how to configure it. So, what does DHCP do? Well, what DHCP does is it dynamically configures hosts, as the name states. But what does this really mean? Essentially, DHCP allocates IP addresses from a predetermined pool in a subnet and assigns them to network devices so that an administrator does not have to do it manually. So, how does DHCP do this? Well, although DHCP makes networking much easier, it still needs to be understood in order to be configured properly. The admin needs to understand the topology of the network that they are working with in order to implement DHCP effectively and properly. DHCP involves working with subnets and remote networks. So, if the engineer does not know what they're doing or what network they're working on, their work will not yield any profit, and it will end up being an ineffective protocol or server. How does DHCP do this? Continued. Firstly, it allocates IP addresses by leasing them from a predetermined pool of IP addresses coming from a predetermined range in a subnet that's specified in a configuration command. This is similar to like renting something from a landlord. You sign a lease. This is what a DHCP server does to a client. Before I get too much into this, I'd like to talk about what happens before the actual pool configuration. So, it's important to understand these interactions between the clients and the DHCP. The first thing that these things do and how they communicate is through requests. There are 4 different types of requests. There is a discover request, which is basically the client saying, hey, is there anybody out there? I'm looking for an IP address. And then the DHCP server will be like, hey, I have addresses. I'm here for you. And then it will, after receiving the acknowledge, the client will then in turn it will request a request. It will ask for an IP address. Say, hey, I need an IP address. I know that you're there. Can you give me one? And then if it has any extra IP addresses, it will offer it. The second type of configuration that happens outside of the configuration pool is exclusions. And exclusions are very important because in some cases there are statically assigned network devices that have an IP address, like I said, that has been statically configured. And if that happens to be in a subnet in which you are DHCP pooling, then DHCP will be more than happy to give out that address to another device. Now, it doesn't take too much imagination to imagine the kind of chaos that can go down when 2 devices have the same IP address. Now, let's get to the configuration of the pool. This is considered the main part of the DHCP protocol. Since the pregame is done, now let's talk about how to do it. There are 6 main steps. First thing is to actually get into the configuration mode. So you have to go into global configuration mode, conf t, and then enter the pool configuration mode by typing in IP DHCP pool and then the name of your pool. After that, enter the ID of the network or the subnet to switch addresses to which addresses will be leased. Do this by entering the network ID and then the mask. Next, you must configure the default router of the subnet or the network that you have just put in the pool. This allows the server to define the default router in a given subnet, which is important. It needs a way to get out. And this will play a role later as well in this presentation. We'll talk about relaying and how important it is with effective DHCP setups. The third part of configuration is telling the router the address of the DNS server. You simply do this by entering DNS-server address 1 and address 2, whatever those addresses may be. It's important to understand why DNS and DHCP need to be working together. DNS is another protocol. It's very similar to DHCP in the concept of it. But DNS is the reason that you can type in google.com instead of typing in Google's IP address, which I think we can all agree would get very obnoxious every time we wanted to enter a website. So DNS's job is to take an IP address and assign a host name to it. Now, you can imagine that these two protocols may get finicky if they're not configured together, because when the IP addresses are constantly being changed and leased, DNS needs to know this information, needs to update its table as well, or else DNS will have wrong tables, wrong IP addresses, different host names, and it will cause all sorts of problems. Now, part 4 of the config is after the DNS server is configured is the lease time. This is a pretty simple concept to understand. This is just simply how long you want to give out an IP address. So you can do it from days, hours, and minutes, and you can make it as long as you want or as short as you like. Now, the 5th part of this, in conjunction with the aforementioned relationship between DHCP and DNS, is now time to define a host name. Do this by issuing the domain-name command. The domain name is another name for a website name. We'll use the same example again. Google is the domain name for whatever the ping address for Google is, or the IP address, not the ping address. Now, the last main part of DHCP configuration is dealing with the TFTP server, which stands for Trivial File Transfer Protocol. TFTP is a simpler version of FTP, hence the word trivial. It is used to transfer trivial files, images, and configurations, among other things. This protocol is important with DHCP because of the use of IP phones and similar devices. It allows easy transfer of files in conjunction with the DHCP server. IP phones are a huge use of this. For example, in a Cisco network or in a Cisco office, you may be given an IP phone. Now, if Cisco wants to load a new configuration onto this phone or give you a file to all these phones within the IP phone range, then all it simply has to do is use TFTP, because it is a much simpler load, per se, than actually using the FTP. FTP is more heavy duty, so there's actually a different protocol for using it for smaller, simpler, more trivial tasks. This command is next-server and the IP address of the server. Now, I mentioned this earlier in the slide. I'm going to get into some advanced configuration. Of course, there are more configurations besides the textbook vanilla DHCP config. One of the most important aspects of this advanced configuration is DHCP relaying. Relaying, with the help of the helper-address command, allows DHCP to pass through routers and access different parts of a network. The IP helper command essentially gives the DHCP packet the IP address of the helper, which grants it to the router. Otherwise, if a packet needs to get outside the local network, it'll go to the router, and that's it. That's the end. There's no helper address set up. To get out of the router, it needs to have a helper address that will take the place of the previous address. And this allows it to go past the router and wherever it needs to be. So, what makes DHCP so great? Well, in the famous words of Dr. Phil, DHCP makes networking easy, and that's the truth. After dealing with imaging these servers, as you know, Dr. Phil, even though it was a kind of a pain, it'd still be a lot easier than manually configuring every single one of these IP addresses on all of these machines. Now, this concept gets even more gratifying at a larger scale. Imagine having to manually enter 3,000 addresses for a corporate company with thousands and thousands of hosts. It would be a nightmare. It's irritating doing it in a small classroom. So, although DHCP may be troublesome to configure and understand, once it is learned and mastered, it can be a wonderful tool for administering IP addresses to clients. To recap, the configuration outside of the DHCP pool configuration includes excluding addresses, which allows certain addresses to be exempt from being pooled, and then requests, which is simply the interaction of the client and the actual DHCP server. This isn't really necessary to know, but it's good to understand what is going on in all the things in networking, rather than just memorizing the words. Now I'll go over the config one more time. First thing you need to do is enter the pool name. You can name it whatever you like, and then define your subnet by using the network command. Next, you need to define the default router in that subnet that you would like to use. This allows the DHCP server to see where the router is, and it's also very important to know your topology and what network you are dealing with. Next, you want to assign the DNS IP address so that the DNS and the DHCP can work well together. After that, you want to lease out your IP address times if you want to do them forever or just a couple minutes. This is where you do it. And then you want to issue the domain name. This is important because it's a lot easier to remember a domain name than it is an IP address, and I think we can all agree, once again, that it's easier to type in google.com than whatever the IP address for Google is. Lastly, you can set the trivial file transfer protocol with the next server command in order to implement this trivial file transfer protocol server, which makes it easy to transfer smaller, more trivial files across networking devices. Now, in conclusion, DHCP is a wonderful protocol that makes networking a little bit easier for people in our profession. It may be difficult to understand at first. Once configured properly, it can work wonders and save tremendous amounts of time. It is best to use when working in association with a DNS server because misinformation can damage a network or information. And as a network engineer, it's our job to make sure that does not happen. Thank you.